Good morning. So today let me continue with the problems on the support reaction. Okay, let me take up a problem. So the problem is like this: determine the reactions at A and E for the beam shown in figure. So I think this is the fourth problem, I guess. Determine the support reactions at A and B. Determine the reactions at A and E for the beam shown in figure. So they have given the diagram like this. Okay, so there is a beam. So here they have given the hinge support. So on the other side they have given the roller support. They have given an load at a distance of 1 meter from support. This is A. So the load that they have given is 5 kilonewton. So this is 1 meter. So next, at 1 more meter they have given a pure moment in anti-clockwise direction. So that they have considered, this is B, this point is C they have given, and the value is 10 kilonewton meter. This is also 1 meter. So from B to C the span is 1 meter. Next, after leaving 1 more meter span, so there is a continuous UDL like this. So this is D, this is E portion. So the UDL that they have given is, it's 2 kilonewton per meter. But here the twist is, they have given one more beam in this particular direction. Okay, here also the UDL is acting. Here also in this span also the UDL is acting, and that particular distance is, so 3 kilonewton per meter. And this span is also 3 meter, and this span is 1 meter. This is 3 kilonewton per meter. Okay, and this particular span from here till here, so it's again 3 meter. So E and the above one is F. So let me check anything that I have left out. So the span is 3 meter, done. So that is not 3 meter, and this is 1 meter. Okay, so this is the question that they have given. Okay, so now what we need to do here is, as they have asked us in the question, we need to calculate the reactions at A as well as at E. Okay, so now let me write the free body diagram for that. So in all the support reactions problem, so first we need to write the free body diagram to solve any problem. Okay, so first what I will be doing is, let me extend a line like this. Okay, let me draw a beam. Okay, so which kind of a support is this? So it's a hinged support. For hinged support, how many number of reactions? So 2 reactions. So one is in vertical direction, I will be calling it as RA, and one more is in horizontal direction, I will be calling it as HA. Okay, so next, a point load is acting. Let me write down the same point load here also, that is 5 kilonewton. So again, at this particular point, so there is an anti-clockwise moment acting, so it's 10 kilonewton meter. So I think you people know that. So whenever we are having an UDL, so we need to convert that into point load. Yes or no? So what I will be doing is, I will be converting UDL to point load. So I think you people remember how to convert UDL to point load. So the formula is W into L. So what is the value of W? That is the load. It's 2 kilonewton meter, 2 kilonewton per meter, into till what span it has been distributed. So it's 3 meter. So this meter get cancelled. Finally we are left out with 6 kilonewton. So finally we are left out with 6 kilonewton. Now I want you people to tell me at what distance it acts from D point. So this is D point, this is C, this is B. This is 1 meter, this is also 1 meter. This span is also 1 meter. This total span is 3 meter. Please remember, this total span is 3 meter. If I want to convert this UDL to point load, so that is the formula, and where it acts exactly? It acts exactly at the center. So 6 kilonewton I have already calculated. So total it was 3. So now it will become 1.5 and 1.5. Okay. So now we are having a roller support. For roller support, how many unknowns or reactions? So only one reaction, and that too in the vertical direction. So it is RE. Okay. So now there is one more beam in this particular direction. Okay. This is F. How to convert this UDL? Please remember, this is also an UDL. Okay. So this is also an UDL. So to convert UDL, the same formula. Okay. Let me call this as the first one. Let me call this as the second one. It's W into L. So W value is 3 kilonewton per meter. So and what is the span? 1 meter. Meter get cancelled. It is 3 kilonewton. And where it acts? It acts exactly at the center. The total span is 1 meter. So the UDL I have converted into point load. It is 3 kilonewton, and this distance is 0.5 meter, and this distance is 0.5 meter. Okay. So this is the free body diagram that I want you people to remember. If you know how to write this free body diagram, all the other steps are easy. Okay. So now, after writing the free body diagram, so I think I have already solved 3 problems. I want you people to tell me. So which is the next step? So applying the equations of equilibrium. So let me apply it. So using equations of equilibrium. So the first one, it is sigma V is equal to 0. Upward direction positive. Yes or no? So now, which are all the forces which are acting in upward direction? So first one is RA, or else we'll go as usual. First we'll go with sigma H, because in all the 3 problems I have first started with horizontal force. There is nothing mandatory that you need to start only with the sigma V is equal to 0, sigma H is equal to 0. Okay. So first we'll go with sigma H is equal to 0. So HA is an horizontal force which is acting in rightward direction. So plus HA. Next, any other forces? Yes. Here we are having one more. So 3 kilonewton is acting in leftward direction. So minus 3 is equal to 0. So can I say HA is equal to 3 kilonewton? So I got the value of this. Second one. Okay. So now let me apply sigma V is equal to 0. Sigma V is equal to 0, upward direction positive. Okay. So RA, it is acting in upward direction. Next, minus 5, because 5 kilonewton is acting in downward direction. Don't consider the pure moment. Okay. Next, minus 6. Anything else? Yes. Plus RE is equal to 0, or else can I say it like this? So RA plus RE, if I transfer these two towards that side, it will become 11. For time being, let me call this as 1. Okay. So let me consider the next one. So which is the next equations of equilibrium? Okay. So it is sigma M. But the thing is, about which particular point shall I take it? So one thing is, clockwise is positive, no doubt. So in the previous classes only I have told you people, at which particular support you are having more number of unknowns, take the moment about that particular point. So as per the diagram, so there are only 2 supports, A and E. Okay. At A you are having 2 unknowns, and HA just now I have calculated, but still where you are having more number of forces, take the moment about that point, because that will become 0 when you take the moment. Okay. So A point I will be taking the moment, because at E point you are having only one particular force. Okay. So now let me take the moment about this point. So please be careful. So now this 5 kilonewton, observe here, the force is acting in this direction. Where I want the moment, okay, in which direction the force is acting? extend the line of action along the direction of the force. Where I want the moment, in which direction the force is acting, extend the line of action. Now, I want you people to tell me whether this particular chalk holder, if it goes in clockwise, it is shortest, or anti-clockwise. Observe. So, this force needs to go and touch it in clockwise direction, that will be shorter. So, force into perpendicular distance clockwise. So, 5 into 1. So, it's, I will be taking about A point. So, it's 5 into 1. Next, let me go further. So, let me go further. We are having a pure moment. As I am considering the moment itself as it is a pure moment, let me go with the anti-clockwise direction. So, anti-clockwise direction negative. So, that is minus 5. So, next, let me come here. Okay. So, now this is 6 kilonewton. This force also needs to go and touch it in clockwise direction. So, plus 6 into, what is this total distance? 1 plus 1 plus 1 plus 1.5, 4.5. So, plus 6 into 4.5. So, plus 6 into 4.5. Next, let me go with this RE. Okay, this RE needs to go and touch it in anti-clockwise direction. So, RE into, what is the total value? So, it's 6. So, minus RE into 6. Okay. Next, we are left out with the last one. There is one more force acting in this direction. Be careful with this. Okay. The force is acting in this direction. Where I want the moment? About A point. So, where I want the moment, in which direction the force is acting, extend the line of action at point A, where I want the moment. If I extend the line, don't you think that it's on the beam only? So, this force needs to go and touch this particular beam, whether it is clockwise or anti-clockwise. So, it is anti-clockwise. So, minus 3 into 0.5. Minus 3 into 0.5 is equal to 0. So, after solving this, so what is the value of RE that I will be getting? So, the value of RE that I will be getting here is, so it's 3.41 kilonewton. It's 3.41 kilonewton. I got the value of RE. So, now let me substitute it in equation 1. So, from equation 1. So, what I need to do? So, RA plus RE is 3.41 is equal to 11. So, what is the value of RA? So, RA will be 7.59. 7.59 kilonewton. They have asked us to calculate the support reactions, and we have already calculated it. But please remember one thing, in the previous problems also I have told you people, at which particular support you are having HA value as well as RA value. Let us check for HA value. What is the value of HA? It's 3 kilonewton. What is the value of RA? So, we got it as 7.59. So, at this particular support we are having two values. So, whenever you are having two values, you always need to calculate the resultant of A. So, next what I will be doing here is, so let me use this particular space only, because let me not rub the entire problem. So, resultant at A, I will be writing it over here. Resultant at A. So, if I want R, I will be calling it as RA dash, which is given by the horizontal force square plus vertical force square. It's a formula, RA square plus HA square. So, please remember this. So, what is the value of RA? So, RA value is 7.59. Okay. So, RA is 7.59 square, HA is 3 square. So, what is the value of RA dash that we are getting? So, it's 8.16. It's 8.16 kilonewton. I want to calculate the directions. So, direction is given by alpha is equal to tan inverse of. Okay. So, it is HA by RA. I think you people remember this formula. So, it's tan inverse of. So, HA is 3, RA is 7.59. So, what is the final value of alpha? So, alpha value is given by, I think I have written it, sorry. So, it is VA by HA, that is RA by HA. Okay. So, this is 7.59. this is 3. Okay. So what is the value? So the value that we are getting here is 68.43. 68.43 degree. So this is how we need to do the problem. This is how we need to do the problem. Any doubts in this? So this is a simple step. The only thing is, first you need to know how to write the free body diagram. Okay. After that, you can easily do the problem. Just apply the equations of equilibrium. So now we'll move on with the next problem. So now let me take up the next problem. Okay. That is the 5th problem, and in this particular class it is the 2nd problem. Okay. Determine the distance x. So it is the 5th problem. Determine the distance x. Determine the distance x such that the reaction at A and B, such that the reaction at A and B, such that the reactions at A and B are equal for the beam shown in figure, are equal for the beam shown in figure, beam shown in figure. So this is the 5th question. Okay. So the diagram that they have given, it is like this. So now they have given a diagram like this. But here, instead of mentioning a particular symbol for the support, like hinged support or roller support, so what they have done is, they have just given an arrow mark. That's it. So here one arrow mark and here one arrow mark. They have called this particular distance as x and an overhanging load, and that is 10 kilonewton. Okay. So next, an UDL for 2 meter. An UDL for 2 meter. So it's 2 kilonewton per meter, and the UDL is for a span of 2 meter. Next, at the end of this UDL, there is a point load. At the end of this UDL, there is a point load. So that's 30 kilonewton. It's 30 kilonewton. So soon after this, at 1 meter distance, soon after this at 1 meter distance, so there is one more point load, that is 20 kilonewton. It's 20 kilonewton, and this span is 1 meter. So be careful. Next, this is 4 meter span. Okay, there is no load for that particular span, and this is x. So they have given this as A and they have given this as B. So this is the question that they have given. So just concentrate on this question. Okay, here what they are asking is, they are asking us to calculate the distance x such that the reactions at A and B are equal. So here they have not mentioned a particular symbol, whether it is a hinge support or it is a roller support. So whenever they give only an arrow mark like this for a support, just consider. Okay. So observe, I will be writing the free body diagram first, because if you know how to write the free body diagram, almost think that the problem is solved. So as this is just a arrow mark, you just write that arrow mark and call it as RA, because it's a vertical load. That's it. Because it's neither an hinged nor a roller as per the symbol. Okay. So now we'll convert that UDL to point load. So how to convert UDL to point load? So UDL to point load. So it's W into L. Yes or no? So W is 2 kilonewton per meter. Span is 2 meter. So it's 4 kilonewton. So where it acts exactly at the center. So it's 4 kilonewton. Total span is 2 meter. So this is 1 meter, this is 1 meter. At this span, we are having a 30 kilonewton acting. Okay. At one more, you are having 20 kilonewton. because they are the point load. So let me not disturb that. But here I have done a small mistake. So this is not 2 kilonewton per meter, it is 10 kilonewton per meter. Okay, so now instead of 2, if I mark it as 10, so it's 10 into 2. Actually, this is supposed to be 20 kilonewton. Okay, this is not 4, this is 20 kilonewton. Okay, next we are having one more support at this particular junction. So because this is RB, only one particular arrow, therefore I will be calling it as RB, and this distance is 4 meter. This is 1 meter. This distance they are calling it as X, and they have called this particular force. They have given it. So it's 10 kilonewton. So this is the free body diagram that I want you people to understand. So now the thing is, I want to apply the equations of equilibrium. So the same procedure, using equations of equilibrium, okay. So the first one is sigma h is equal to 0, rightward direction positive. But the thing is, whether you people are able to see any horizontal load? No. Then why you want to apply sigma h is equal to 0? So whenever you don't have any horizontal forces, there is no need to apply sigma h is equal to 0. So forget about that. So let me go with the next one. Sigma v is equal to 0, upward direction positive. So we are having the vertical loads. So the first one is RA, okay, acting in vertical upward direction, so positive. Next, minus 20, minus 30, minus 20. Minus 20, minus 30, minus 20. Next, there is one more, RB plus RB. There is one more which is acting in downward direction. So it's minus 10 is equal to 0. So finally, RA plus RB, so will be equal to 70, 80 I guess. So RA plus RB, it is equal to 80. Yes or no? Now the thing is, in the question itself they have given a clue. So what is that clue? So determine the distance x such that the reactions at A and B are equal. They are telling that the reactions at A and B are equal. So can I use that particular concept? So RA, let it be. Instead of RB, I will be substituting it RA again. The reason is they have only given it in the question. Is equal to 80. So 2 times RA is equal to 80, or RA is equal to 40 kilonewton. If RA is 40, obviously what will be the value of RB? That is also 40. But here what I will be mentioning is, because RA is equal to RB, but I am not in need of RA and RB. So what is the question that they have asked? Find the distance x. So now I need to take the moment about the supports. Either you need to take about A or you need to take about B. Whichever the point, you can go with it. I will be going with A only. So let me see. So second one, sigma MA is equal to 0, clockwise direction positive. Okay, so now let me take the moment about A point. So let me come from that end, or let me go with this only. So don't you think that this 20 kilonewton, it should go and touch it in clockwise direction? So 20 into 1, so plus 20 into 1. Next, there is one more, 30 kilonewton. This force also needs to go and touch it in clockwise. So 30 into 2 plus 30 into 2. Next, again, this one more 20. So this 20 into 3 plus 20 into 3. Okay. So next, we are having RB. RB, don't you think that it is acting in upward direction? So I want, the force is acting in this direction. I want moment about this point, extend the line of action. So don't you think that this force needs to go and touch it in anti-clockwise? So anti-clockwise means negative. RB value I know. What is the value of RB? 40 kilonewton. So minus 40 into 7. So minus 40 into 7, because the total span from here to here is 7 meter, 4 plus 3. The last one is this. So this 10 kilonewton, it should go and touch it in clockwise direction. So 10 into total distance. So it is 7 plus x. So clockwise 10 into x plus 7. So use the calculator, that is the solve option, directly you will get the answer. So the value of x is 7 meter. The value of x is 7 meter. Using the calculator, if you solve, the value of x is 7 meter. I want you people to try it out. Okay, whatever the value that I am having in my book, I am writing it. Okay, if there is any mistake, so while calculating, using the calculator, you people correct it there. Okay, so this completes the 5th problem. So now let me move on with the next one. Okay, first let me rub this. Let me take up the next one. Determine the reactions at the support for the beam shown in figure. 6th one I am taking. Determine the reactions at the supports. Determine the reactions at the supports, at the support for the beam shown in figure. For the beam shown in figure. Beam shown in figure. So the diagram that they have given is like this. I think you people remember which type of a support is this. So it's a fixed support. So the diagram is like this. So the UDL that is acting, they have given it as 10 kilonewton per meter. So the span they have given is, this is 2 meter and this is 2 meter. This they have called it as A, this point is B and this point is C. So at the end there is one more point load acting, that is 10 kilonewton. That is 10 kilonewton. Okay, so now this A, B and that is C point. Okay, so now they are asking us to calculate the reactions at the supports. So any support reaction problem, first we'll draw the free body diagram. Okay, so now B point and this is C point. Let me draw a beam. Which kind of a support is this? It's a fixed support. For a fixed support, how many number of reactions that you can expect? So totally 3 reactions you can expect. So one is in the vertical direction. So I will be calling that as RA. One more is in the horizontal direction. I will be calling it as HA. And one more is the moment. So for time being, I will be calling this as clockwise. I will be calling it as MA. Okay. So now I want to convert that UDL to point load. How to convert UDL to point load? So it's W into L. So what is the value of W? It's 10 kilonewton per meter into, what is the span for which it has been distributed? So it is 2 meter. Meter get cancelled. It's 20 kilonewton. At what distance it acts? It acts exactly at the center. So it's 20 kilonewton. So this is 1 meter, this is 1 meter. And as usual, this is 2 meter span and this is a point load that is acting. So it's 10 kilonewton. Okay, so this is the free body diagram. It's a very simple free body diagram because in all the previous 5 problems, so we have come across the hinge support and the roller support and a normal simple arrow marks. But this is the new one. It is a fixed support where you people will be dealing with 3 reactions. Okay, so now as usual, using the equations of equilibrium, using equations of equilibrium, equilibrium. So what I need to do? Observe. So here any horizontal force? Yes, we are having an horizontal force HA, but as it is only a single force, so first one, sigma H is equal to 0, rightward direction positive. So we are having only one horizontal force, that is HA, that it is acting in rightward direction. So HA, we don't have any other force, so equate it to 0. Second one, sigma V is equal to 0, upward direction positive. So here we are having RA, which is acting in upward direction. So it is RA acting in upward direction. Next, minus 20 kilonewton is acting in downward direction. There is one more point force which is acting in downward direction. So is equal to 0. So don't you think that? So RA is equal to 30 kilonewton. Yes or no? So now we are left out with the calculation of MA. So let me go with the calculation of MA. So now let me take the third one. Sigma M about A is equal to 0, clockwise direction positive. Okay, so now this 20 kilonewton, it needs to go and touch it in clockwise direction. So 20 into 1, clockwise means positive. So 20 into 1. Next, there is one more point load which needs to go and touch it in clockwise direction. So 10 into 4. So plus 10 into 4. Now be careful. So there is a pure moment MA. Even though it is acting about A, okay, so as it is a pure moment, I need to consider it. Okay, these two forces I can neglect it because force into perpendicular distance. Where I want the moment and the force, they are passing through the same point. But whenever you are having a pure moment about the same point, you need to consider the pure moment. So what is the value of pure moment? So the value of pure moment is, I have assumed it as clockwise, so it is plus MA is equal to 0. So MA, it is saying that, so minus 20 minus 40, so minus 60 kilonewton meter, or else I can say MA is equal to 60 kilonewton meter in anti-clockwise direction. So if you mention like this, that is more than sufficient. So any doubts here? So we have completed 3 problems in this class. So now let me move on with the fourth one. Okay. So now let me move on. Find the reactions at A and B for the figure shown below. I will be rubbing this. Shall I? Determine the reactions at the support A and B. Support A and B for the beam shown in figure. Beam shown in figure. Okay, so this is the question that they have asked. Let me write the diagram for that. Okay, so the diagram that they have given us, let me go a little bit faster. So one side they have given it as hinge support. One more side they have given it as roller support. Okay, so now they have given a point load. Span is 2 meter and the point load is also 2 kilonewton. After 1 meter span, they have given a pure clockwise moment, that is 4 kilonewton per 4 kilonewton meter. So next, after 1 meter, so they are having a UDL. So after 1 meter they are having a UDL. So be careful. So here they have given a point load. Be careful. So this span is 2 meter, or we'll do one thing. It's exactly at the center. It is acting exactly at the center. So this is 2 meter, and again this is also 2 meter. So totally UDL is for 4 meter. So exactly at the center there is a point load. So what is that value of that particular point load? It's 10 kilonewton. It's 10 kilonewton, and the value of UDL is 5 kilonewton per meter. Okay. Not only that, they have given one more thing. So they have given a vertical loading. They have given a vertical loading. So it is acting in this pattern. It is acting in this particular pattern. Okay. So the value of this. So it has been given as 3 kilonewton per meter, and at this particular junction they have given the value as 1 kilonewton per meter. So the span that they have given, is 3 meter. The span that they have given is 3 meter. So now the problem is little bit tough, I can say, because the number of support is same, but the number of loadings are more. Let me mark the naming. This is A. So directly they have given only this point. This is B. Only that's it. So they are asking us to calculate the reactions at the support. Quickly let me write the free body diagram for this. As it is a point load, let me mark it here. Okay. So now there is one more vertical beam. So let me mark it like this. Okay, this is B portion, this is A portion. Let me go fast. So this is an hinged support. So for hinged support, how many reactions I can expect? 2. So one is in RA, vertical direction. One more is HA, horizontal direction. Okay, next, there is a point load which is acting. So this is 2 kilonewton. This is 2 meter. This is 1 meter. So now this is 4 kilonewton meter. This is 1 meter span. Now, please remember there is already a 10 kilonewton point load. First, let me mark that. It's already a 10 kilonewton point load. Now, forget about the point load. Let me concentrate on the UDL. So now, how to convert UDL to point load? UDL to point load. So it's W into L. So what is the value of W? 5 kilonewton per meter. Yes or no? Into what is the total span? 4 meter. So don't you think that it's 20 kilonewton? But where it acts? It acts exactly at the center. Observe here. What is the total span of this UDL? 4 meter. Exactly it acts at the center. The 20 kilonewton, it acts at center. Center means at this particular line. But already on this particular line 10 kilonewton is there. So on that itself there is one more load acting. Okay, so that is 20 kilonewton. Don't get confused. If instead of giving it exactly at the center, this 2 meter, instead if they would have given it 1 meter, so the 10 kilonewton would have been here. So then here 10 kilonewton, here 20 kilonewton. But here what is happening? This 10 kilonewton point load is also exactly at the center. Whenever we convert the UDL to point load, that also acts exactly at the center. That's why this combination. Now, as this is a roller support, I can expect only one. Now, but here, this is very important. Observe, this is neither an UDL. I think while explaining the uniformly distributed load, observe here. The UDL should be either in this particular pattern or it should be in this particular pattern. Please remember, either the UDL should be shown in this particular pattern or in this particular pattern. But what about this? It's neither the first one nor the second one. So I don't have any particular formula for this. So what I will be doing here is I will be doing some alterations. So what is that alteration? Observe here. Can I draw a line like this? Sir, what will happen if I draw a line like this? The thing is, don't you think that I have divided the entire diagram into two standard geometrical diagrams? Or instead, can I say it like this? This particular portion, don't you think that it appears like a UDL? And what about this particular portion? Don't you think that It's a UVL, uniformly varying load. So that's why I will be separating it like this. Be careful now. So what is this particular thing? It's a UDL. What is the value of this UDL? 1 kilonewton. So throughout it is 1 kilonewton. So be careful. So this 3 kilonewton, I will be splitting it like this. So this I will be marking it as 1 kilonewton per meter, and this one I will be marking it as 2 kilonewton per meter. Totally it is 3 kilonewton per meter, no doubt. But as I have divided, okay, so now I want to convert this UDL to point load. Now let me go fast. UDL to point load. Okay, so W into L. So what is the value of W load? 1 kilonewton per meter into. So till what span this has been distributed? So it's 3 meter. Meter get cancelled, it's 3 kilonewton. And where it acts? It acts exactly at the center. So if this is total is 3 meter, at 1.5, the value of 3 kilonewton will act. So this is 1.5 and this is 1.5. So this is about the UDL. Now I will be converting the UVL. So UVL also I want to convert to point load. So I have already explained you people what is the formula to convert UVL to point load, WL by 2. So what is the W value now for UVL? It's 2 kilonewton per meter. Into what is the span for which it has been distributed? 3 meter divided by 2. WL by 2. 2 get cancelled, meter get cancelled. Again it is 3 kilonewton. Where it acts? From 90 degree side. From 90 degree side at a distance of L by 3. Yes or no? So now this is 90 degree side. What is the total span? 3 meter. So L by 3 means 3 by 3. So 1 meter from 90 degree side it acts. So be careful. So from 90 degree side it acts at a distance of 1 meter. For time being I will be rubbing this. This 3 kilonewton. Okay, UVL. It acts at a distance of 1 meter from where? From 90 degree side. From 90 degree side 1 meter. So total how much? 3 meter. If this is 1.5, this is 1. Don't you think that this is 0.5? So be careful. This is very, very, very important. So I think you people have understood the free body diagram. So now let me just move on with the equations of equilibrium. I will be rubbing this. Okay. So now let me go fast. Using equations of equilibrium. Using equations of equilibrium. Now we will be having more horizontal force. Yes or no? Sigma H is equal to 0. Rightward direction positive. So how many forces we are having? HA, which is acting in rightward direction. So positive. Next, here, please remember, there is one 3 kilonewton leftward and one more 3 kilonewton. So minus 3 is equal to 0. So don't you think that HA is equal to 6 kilonewton? Second one, let me go with sigma V is equal to 0. That is upward direction positive. Okay, so RA, which is acting in upward direction. Next, minus 2 kilonewton, which is acting in downward direction. Next, here minus 20 minus 10. Minus 20 minus 10. Okay. Next, there is one more force which is acting in upward direction. That is RB. So, RA plus RB is equal to 30. For time being, let me call this as 1. So now, let me move on with, and one more thing, observe here, RA, it is acting in upward direction. So I have forgot about, I have forgot this particular value, minus 2 kilonewton, be careful. So RA, it is acting in upward direction. I have forgotten this, so it's minus 2. So don't you think that? It's 32. Now, let me take moment about any point. I will be taking about A only. The reason is more number of unknowns at point A. At B only one unknown. So here to unknown I will be taking about this point. So now 2 kilonewton force into clockwise distance. So 2 into 2. So clockwise 2 into 2. Next, there is a pure moment which is clockwise. So plus 4. Next, this 10 kilonewton, let me mark this. This is 2 meter. This is also 2 meter. So this 10 has to go and touch it in clockwise direction. So 10 into 6. So plus 10 into 6. There is one more. 20 kilonewton. This 20 clockwise. So 20 into again 6. So plus 20 into 6. Now observe. RB, which is acting in upward direction, it has to go in anti-clockwise direction. So minus RB. Minus RB, what is the total span? 4, 5, 6, 8 meter. It is 8 meter. Not only that, still, observe here, I want moment about this point, A point. There is a force acting in this direction. Okay, I want moment about A point. In which direction the force is acting? Horizontal. Let me extend a line. Don't you think that it comes on the beam? So this force has to go and touch the beam. So this force has to go and touch the beam in anti-clockwise direction. So minus 3 into 1. Minus 3 into 1. Again there is one more force. That also needs to go and touch it in anti-clockwise direction. So minus 3 into 1.5. Minus 3 into 1.5 is equal to 0. So finally I will be getting the value of RB. So what will be the value of RB? So the value of RB is 23.56. 23.56 kilonewton. So from 1, substitute it. So RA only I need to calculate. RB value is 23.56 is equal to 32. So what is the value of RA then? So the value of RA will be 9.44. It's 9.44 kilonewton. Okay, we have calculated the support reactions, that is HA, RA and RB. But from the starting only I am telling that at a support, when you are having two values and both the values are known, okay, you need to calculate the resultant. So what I will be doing, so resultant at A, resultant at A. So RA dash I will be calling, which is given by RA square plus HA square. So RA square, what is the value of RA? Just now I have calculated, it's 9.44 square. What is the value of HA? It's a 6 square. What is the value of RA dash? So RA dash is 11.18 kilonewton. 11.18 kilonewton. I want to calculate the direction. So tan inverse of sigma V. V means vertical reaction, RA, by HA. So it's tan inverse of 9.44 by 6. So the value of alpha. So the value of alpha, 57.56. 57.56. So this is how we need to do the support reaction problems. Okay, so for time being we'll wind up. We'll continue it in the next class. Thank you.